Hello, good morning dear students. Welcome back. In the last class we discussed about linear momentum, isn't it? Today we are going to discuss about Newton's second law of motion. So let's go to the linear momentum section again. See, if I have an object and it's moving with a speed of 5 meters per second, its mass, let it be 1 kilogram. Let it be 1 kilogram. It is moving with a speed of 5 meters per second. What will be its linear momentum? We know the equation for linear momentum is P equal to m into v. As the mass is 1 kilogram, 1 into speed, that is 5. 1 into 5 gives 5. So its linear momentum will be 5 meter per second, isn't it? Sorry, 5 kilogram meter per second. Unit of linear momentum is kilogram meter per second. 5 kilogram meter per second will be its momentum. How can we change the linear momentum? How can we increase its linear momentum? We can't increase the mass of this duster. I can only increase which thing? Velocity, isn't it? How can I increase the velocity? I'll give him more force on this duster, so that we have to apply an external force in order to make a change in the linear momentum of an object, isn't it? So after the what we can say explanation of linear momentum, Newton formed a law based on some explanations from the linear momentum. That is, to make a change in the linear momentum, we have to give an external force. So Newton's second law, or Newton says that according to Newton's second law, the rate of change of linear momentum is directly proportional to external force applied on the body. What is that? Rate of change of linear momentum. That is, change in linear momentum is directly proportional to the force applied on the body. So let's go to that section. We will be discussing mathematical formulation and definition of 1 Newton in this section also. Let me tell once more Newton's second law. According to Newton's second law, the rate of change of linear momentum of a body is directly proportional to the external force applied. That is, we have to apply some external force in order to increase the speed. If the speed is increased, then linear momentum will also increase. What happens if we apply a force in the opposite direction to the motion? Then it decreases the speed and hence linear momentum is again changed. So in order to make a change in the linear momentum, obviously we have to apply a force, external force. That is Newton's second law. Once more, Newton's second law says that rate of change in linear momentum is directly proportional to the external force applied on the body, and the direction of motion will be in the direction of application of force. That means motion and force will be in the same direction. Let's write that rate of change in linear momentum What is the meaning of directly proportional to? Directly proportional to. I am repeating the word directly proportional to. Directly proportional means if one quantity increases, or by its effect if the other quantity also increases, that is called directly proportional. That means if in your house you have, in your home you have water tanks, isn't it? What happens in the water if the water level in the water tank increases? When you open the tap, with more force the water will come, isn't it? Water will be flowing down with more force. So this water level in the water tank is proportional to the speed of flow of water. When the water level increases in the tank, speed of flow will be increasing. That is directly. We can say water level is directly proportional to the speed of flow of water. That is the meaning of directly proportional. If one quantity increases, by effect of that quantity, if other quantity too increases, then they are directly proportional to each other. See here, rate of change of linear momentum is directly proportional to, and the symbol of directly proportional. They are directly proportional to external force applied. For external force I am giving here force only. So here rate of change in linear momentum is directly proportional to force. Do you heard the word rate anywhere else? Yes, in the definition of acceleration, isn't it? What was the definition of acceleration? Rate of change of velocity, isn't it? That is why we write v minus u by t. Hence here rate of change in linear momentum. If there is a linear momentum p1 and p2, initial linear momentum and final linear momentum of an object. For example, let this duster itself. It's initially moving with 5 meter per second. After applying some more force, it is moving with 10 meter per second. And what happens? Its initial linear momentum is 5 kilogram meter per second and final linear momentum will be 10 kilogram meter per second. Isn't it? So there is an increase. It's 10. Initially it was 5. So the change in linear momentum is 5. Isn't it? 10 minus 5. Such like that. If there is two momentums, that is initial momentum and final momentum, change in linear momentum will be p2 minus p1. Once more, p2 is the final linear momentum and p1 is the initial linear momentum. Okay, fine. And whenever we see rate of change, there will be the application of time, the presence of time. Wherever we see the equation in the definition, if there is rate, there will be divided by t. Rate of change of velocity v minus u by t gives acceleration, isn't it? There also you can see a t. Rate of change in the distance, that is velocity, distance by time, that gives velocity. Here we can get a displacement by time gives the velocity, and velocity by time gives acceleration, isn't it? V minus u by t gives acceleration. Hence, like here, rate of change of linear momentum, that is p2 minus p1, that is change in linear momentum. Rate of change means divided by t. Once more, Newton's second law states that according to Newton's second law, rate of change of linear momentum is directly proportional to force, and we are going to write its mathematical formula. Change in linear momentum is obviously if there is two linear momentums, p2 minus p1, and if there is rate, we will divide it by t, proportional to external force F. Now consider a body that is having, this is a body that is having mass m, and initially it is moving with the velocity u, initial velocity u. After some time t, the same object is moving with, that is with mass m, the same object that is moving with initial final velocity v. Then here we have initial velocity, here we have final velocity. What is the momentum here? The equation of momentum, m into v. M is m here, v is equivalent to u. So p1 is equal to mu. Now final momentum, that is equation, again the equation for linear momentum is mass into velocity. Here mass is m, velocity is v, that is mv. Mu here, mv here. Now we can substitute the values of p1 and p2 in this equation. So we will get mv minus mu divided by t proportional to f. What I done here? Substituting the values of p2. p2 is equal to mv, p1 is equal to mu, that is initial linear momentum and final linear momentum, divided by t proportional to f. The same thing here. Now let me continue it here. Okay, let me continue it here. So mv minus mu divided by t proportional to f. Here you can see m, that is common in these two terms. So we can take the common term outside, m. What will be coming in the bracket? What is left here? V, and what left here? U, and in between there is a minus. So it becomes m into v minus u. Why do we take m outside of the bracket? Because m is a common term in this both mv and mvu. That's why we take m outside. So we make a bracket here as m is a common term, and the left one, when we take m, v left here and u left here, so we take m into v minus u divided by t proportional to f. What is v minus u by t? You are very familiar with this equation, v minus u by t. Yes, that's the equation for acceleration, m into a proportional to f. See here, from this big equation we reach at ma proportional to f. Now we have to remove this proportional sign. So whenever we are removing proportionality sign, let it be in mathematics or physics or chemistry, whenever you are removing a proportionality sign, you will be introducing a constant. Instead of proportionality sign, we will be introducing equal to and a constant along with equal to. That is, our equation becomes ma equal to k into f. K into f. Why we are putting this equal to and k together? That is, if you want to remove proportionality sign, and we have to introduce a equal to sign. So actually we need an equal to sign here, because we can't do any problem if it is proportionality sign in the equation. So we are making an equation, and in that equation there should not be any proportionality sign. So in order to remove this proportionality sign, we are introducing an equal to sign, and if you are introducing an equal to sign, there will be a constant term along with the equal to sign. This k is called constant of proportionality. K is constant of proportionality. You have to completely write that, constant of proportionality. And later Newton conducted many experiments and find out that the value of k is equal to 1. The value of k is equal to 1. Now the equation becomes ma equal to 1 into f. What is 1 into f? Value of k equal to 1. So it is 1 into f. 1 into f means f itself. Hence we got f is equal to ma. That is the mathematical formulation of the equation of force from Newton's second law, or the mathematical formulation of Newton's second law. We formed an equation for force, F is equal to ma. This is very important equation, and you can expect it in 5-mark question. That is, derive an equation for force using Newton's second law. So you have to state Newton's second law. What is Newton's second law? According to Newton's second law, rate of change in linear momentum is directly proportional to what? External force applied. And then we have to write the mathematical formula, that is, change in linear momentum divided by time taken is proportional to force. Change in linear momentum is P2 minus P1 divided by T proportional to F. Now P2 is final linear momentum and P1 is initial linear momentum. Initial linear momentum means m into u, and final linear momentum is m into v. Why it becomes u and v? It's initial velocity and this is final velocity. mv minus mu divided by t gives, or is proportional to f. Now taking the common term outside, from this we can see that m is common, and we take the common term outside, it becomes m into v minus u by t, and this equation is very familiar for us, that is v minus u by t is equal to a. So the equation becomes ma proportional to f. Now we have to remove this proportionality sign, so we have to introduce the equal to sign along with a constant, that is m equal to k into f, where the value of k, or its constant of proportionality, and its value is found to be 1. So we can write ma equal to f, or to beautify our equation we can write it as f is equal to ma. Make it in a box and state the equation for force and derived from Newton's second law. So you can expect questions from this side. Now we have to derive a unit for force. See, who formed this equation for force? Newton, isn't it? So in order to honor Newton, in order to give an honor to Newton, the scientists give the unit of force as Newton. So unit of force, SI unit. SI unit of force is Newton. Actually, what will be the unit? For mass it is kilogram. For acceleration it is meter per second square. Actually the unit have to be kilogram meter per second square. But in order to honor Newton, we made the unit of force as Newton. Now come to the equation F is equal to ma. We understand the unit of force is Newton. Let us give the units in this equation. For F we can give 1 Newton. For mass we can give 1 kilogram. That is the unit of mass, isn't it? Unit of acceleration is 1 meter per second square. So you can expect a question, define 1 Newton. For that question, first of all you have to write the equation F is equal to ma. Then you have to write the units of F, m and a. That is 1 Newton is equal to 1 kilogram into 1 meter per second square, where Newton is the unit of force, kilogram is the unit of mass, meter per second square is the unit of acceleration. See now, then you have to define Newton in words. So we can define 1 Newton as the force which makes 1 meters per second square acceleration on a body which weighs or which having a mass of 1 kilogram. So 1 Newton is that force which makes an acceleration of 1 meter per second square in a body of 1 kilogram. So that is the definition for 1 Newton. See here, F is equal to m into a. Acceleration is scalar quantity or vector quantity? It's a vector quantity. Hence, force is also a vector quantity. That means force have both direction and magnitude. Vector quantities have both direction and magnitude. Already we discussed the case of linear momentum. Linear momentum was a vector quantity, isn't it? We discussed it so. As such, force is also a vector quantity as acceleration is a vector quantity. So that's all about the section. Today we discussed Newton's second law, then mathematical formulation of the equation F is equal to ma from Newton's second law, definition for 1 Newton. So these are the 3 questions you can expect from this section. Thank you for watching. If you have any doubt, see once more the video, and if your doubts are not cleared, you can contact me. Thank you for watching. Have a nice day.